Pyramid. Pyramid. Big difference about a pyramid. How many bases on a pyramid? Just one base. Okay, not two anymore, just one base. Quick introduction to a pyramid here, just so we're good. This is probably the first time many of you, other than in probably textbooks, have seen a pyramid. The base. I don't care what shape it is, it's always going to be a regular base. We've talked about that term before. What's it mean for a shape to be regular? Romeo?
It all has the same side measures.
All the sides are equal. So in any pyramid we deal with, mostly it's going to be a square. But if it's not, you can assume all the sides are equal on the base. And then take off the base of a pyramid. What's left? Triangles. Triangles. All right? So what's going to be left are congruent isosceles triangles for non-bases. All right? Assume all the triangles are congruent that are left. All right? Assume all the triangles that are left are congruent. Here's the thing I need to push through today, and this is going to be mind blown. In a pyramid, you have two heights. Okay? You have the height of the actual pyramid, and then you have the height of one of the triangular faces. Those are two different heights, the height of the pyramid and the height of the triangular face. Here's how I'm going to describe both to you so you remember. Anybody ever see any of the movies, Tom Cruise, Mission Impossible? Kind of familiar with it? He does all these dangerous stunts all over the place, right? This is what you have to get yourself into Mission Impossible mode. And here's what I mean. When you think about both heights. So here you go. You're going up to the top of the pyramid. All right, sorry. All right, you got to go up to the top of the pyramid here. You are at the very top. You know that pointy top? You're at the top. You're on the inside. It's called the apex, if you want to impress your friends later on. Called the apex. You got nothing on you but your rope to get down. All right, so pretend you're at the apex right now and you got nothing but your rope to get down. All right, you drop that rope. There we go. You drop that rope all the way down. So it's perpendicular. Everyone see this right now. This is the height. Everyone good? This is the height, the altitude of the pyramid. Everyone's got that. You have another word on there that's got height in it. What is it? Slant height. Everyone see one of the faces that are triangles? That's the slant height, the height on one of those faces. See the difference? This right here, apex all the way down, is your height of the pyramid, the altitude. Slant height, that's the height on one of those triangular faces. Everybody good with the difference? All right? We're going to talk about both here right now. All right. So again, on the face right here, that is slant height. But when I drop it straight down to the base, that's my height. I'm going to sometimes call it Mission Impossible height. All right? Real quickly, I'll get back to this too. See where it's pointing to, 8 feet? Is that the height of the pyramid or the slant height then? Height of the pyramid. That's your Mission Impossible height. Good? All right. How about lateral area of a pyramid? Lateral area. What did we talk about yesterday? You want to find lateral area, what do I have to take off? Bases. So take off the base and what's left? In this case, 4. So how can I find the lateral area of a pyramid? I take the number of triangles and multiply it by area formula of a triangle last unit. Done. That's how you find lateral area of a pyramid. All good? Think we can do it for this one. Let's figure it out. Let's take our pyramid here. Lateral area. How many triangles? How many triangles? 4. times the area of one of them. So I'll take this one right here. What's the base? I already know. It's labeled. What's the base? Okay. 4 times 1/2 times 12. Can I use the 8 as the height? No, that's the height of the pyramid. I'm trying to find the height of that face right there, which is called my what? Slant height. Oh, I can do the 1 hour one, huh? I'm good. I've heard that. All right. So now that's what I'm looking for, my slant height. Knowing what we've done all year. Look at my figure now. Haven't I just made a right triangle? Guess how I'm going to find the slant height? Pythag, you're darn right. But there's a little other piece here that we're going to run into. So yeah, let's do Pythag to find the slant height. What's one side you already know? 8. Here's the problem though. Everyone see the other leg? It's not labeled, but you can assume it's always half the base. If the base is 12, this is going to be 6. And then my slant height is the hypotenuse. Okay, so hopefully you're starting to pick up the difference between slant height versus the height of the pyramid. Slant height comes out to be 10, and that's the height of the slant height of that triangle. And there's your lateral area for the pyramid. Number of triangles times 1/2 base times height. And what do we got there? That's 2, 24, 240. Still what type of units? Feet? Feet? Squared. Still talking area here. Are we okay? Take off the base, find the area of one triangle, multiply by how many there are. We're all good. Next, surface area. Now put the base back on. Right? Lateral area plus how many bases? One base. So here, take a look. I'm just going to put a capital B there. Don't get confused. All I'm saying is that's the area of the base. Did I leave the special one on here? Yeah, I did. Don't assume it's always going to be a square. You're going to see one that's not a square coming up in a few problems. So same pyramid I gave you guys on the previous page. So let's find its surface area now. You did the hard work. What was the lateral area again? 240 plus, how do you find the area of that base? It's a square. Length times width, base times height, so plus 12 times 12. Now I just add in the base. That's it. Guys, I don't have any magic formulas for you here. It's just understanding what lateral and surface area is. And I have 384 feet squared. Breath, we all set? All right, now I'm going to start calling out numbers left and right here. Find the lateral area. Take off the base. I still have how many triangles because it was a square? 4 triangles times 1/2 BH. Ooh. Ready? Let's see who's up here. 15. What's the base of one of those triangles? 10. Good work. Ooh, here we go. Are we picking this up or not? Because I'm not getting on desks again. 5. Can I use the 13 as the height? Who's 5? 5? Is this the height of the pyramid, Jackson, or is that the slant height on the face? Okay, so guess what? It's going into the formula. Everyone good? Why I don't need to use Pythag? Yes? No? Okay, I don't need to use Pythag here because I'm looking for the height on the triangle, which they give me is 13. All right, go ahead. Crunch away. 260 square inches. Anything I could answer? And I usually get a lot of complaints about this next one. Why did you draw it upside down? Flip your paper over. Relax. Okay, if you don't like it. I can't see anything. How many triangles still if I'm going to take off the base? Still 4 triangles. All right, let's see who's got this one. Take one of the triangles right now for me. You can highlight it, darken it. I don't care. Take one of the triangles. 16. What's the base length on one of the triangles? 7. Got it. 17. Can I use this 7 right here that they're pointing to for the height of one of those triangles? Anybody got 17? 17, anybody? Number 17? 17? Nobody? All right. How about 8? That's you, Colin? I'm sorry, I thought it was somebody else. Can I use that 7 there as the height of the triangular face? No, that's the height of the pyramid. That's why I got it on the desk there. That's the height of the pyramid. So that 7's not going to be plugged in there. How can I find it, though? I can use Pythagorean Theorem. A squared plus B squared equals C squared. All right. Let's go to number 12. Give me one leg length here. So 7 squared plus, what about the other one? Not 7 again. Remember what we do? We take half the base, right? Half the base, 18, half the base. 3.5. Plus 3.5 squared equals C squared. Yep, good, everyone, good? And you're not going to get a nice number here, right? You're taking the square root of what? 61.25? All right, don't round it. Whatever you do, don't round it. But I'm just going to, everyone take a look. I'm just going to put it up here. Square root of 61.25, that decimal you're getting. Don't round it. I'll go ahead. You crunch your numbers. I'll ask for somebody with the lateral area to the nearest 10th here in a minute. Take off the base. Nearest 10th, take your time when you're ready. Oh, 10!
109.6.
Darn right. Anything I can help you with here? All right, so let's get a surface area one in now. Find the surface area. So everything, right? Lateral and then the area of the base at the end. I'll get to that. I'll get to it last, I guess. All right, so 4 triangles times 1/2. What's the base length of one of the triangles there? Hey, 9, base length of one of those triangles. 5. 3. Can I use that 12 they're pointing to? No, cannot. That's the height of the pyramid, not the height of the triangle. So Pythag again, right, everyone? Pythag. Let me know what's going into Pythag here. 6. Little help with Pythag. What's one side of the right triangle? 12 squared. How about the second side? Good job not doing 5. Half of the base, 2.5. Squared equals C squared. Good work, Luke. I don't think you're going to get a decent number here either. What are you guys getting? Square root of 150.25. And now, because I'm asking surface area, add in the base. How do you find the area of the base? Just a square. 5. Jackson, how do I find the area of that base?
5.
Yep. Good work, everyone. Nearest 10th when you're ready. Oh, 17, nearest 10th when you're ready. We don't have one today, huh? I'll just be awkward silence. 11.
The answer? 147.6 meters squared.
George, you good?
Yeah.
Good talk. All right, I just can't have you guys do square pyramids. I can't. You guys are above average class. I got to expose you to something else. So take a look at this one, hexagonal base. Don't start freaking out. You guys can do this. We did it last unit. First thing, surface area. All right, now how many triangles am I working with? How many triangles? 6 now. Everyone, yes? Not 4 anymore, 6. 1/2. What's the base length of one of those 6 triangles? 6? Ha! 6 times the height of one of those 6 triangles. You're welcome. 11.
12.
It's already there. It says, hey, slant height's 12. That's the height on one of the triangles. So is everybody good right here? This is the lateral area. Now comes the tough part, right? Now I have to add in the area of that base, which is in what shape again? Hexagon. Ooh, yeah, we got to review how to find the area of a hexagon from last unit. I'm not skipping it. Okay, how do I find the area of this hexagon that's got a side of 6 meters? Let's dig deep and review. Remember what we did? We cut it up into 6 triangles. So we're finding big B right now. 6 triangles, 1/2. What's the base of one of those 6 triangles up here? 6. Everyone with? Hey, good. 6 is the base. Now I need your help finding what the height is. Remember what this is going to turn into? I don't want to use sine and cosine. Takes too long. Yeah, I want to use 30, 60, 90 here. What's this angle here, this full angle? Anybody remember how to get it? 360 divided by 6 is 60. Cut it in half. So this is going to be a 30-degree angle, 60-degree angle. What else is being cut in half? This 6 is being cut in half, remember? So I'm not going to use 6 in my calculation. I'm going to use 3. All right, 3 is the shorter leg. What's the longer then? 3 is the shorter. What's my longer? 3 times radical 3. So there's your height. So all of this right here, take a look. All of this is the area of the base that I'm going to plug into with the lateral area. Oh boy, everyone relax. Typing like you're texting. When you're ready, nearest 10th. When you're ready. Ooh, 9?
93.5.
Whoa. 93.5. You sure? At the lateral area alone, Romeo, I get 216.
Oh, both of them.
Yeah. I want this whole surface area.
309.
Point.
5.
Thank you. Do not skip it tonight on your homework when you get a hexagon tonight. Don't skip it. You know what the deal is. All right. Anything here before we end it like we ended it yesterday? 2 figures on top of each other. Find the surface area. You can only do what's showing, right? What's showing. All right. What's on top? 8, what's on top? What's that figure on top? Pyramid. What's the figure on the bottom? 10.
Rectangular prism.
Good vocabulary. And then we're going to add them together. Pyramid. What's the only thing? What's showing on the pyramid? What's showing on the pyramid here? I got the slant height here. Is the base showing? Or is the base covered up? Covered up, so don't count it. So what's the only thing showing? How many triangles? So that's the only thing you should be calculating here, because the base is being covered up. 4 times 1/2. What's the base of one of those triangles? 2. What's the base length of one of those triangles? 6. Good work. What's the height of one of those triangles? 3. 4. That's it. Don't say plus 6 times 6. So what do I got there? 48? Yeah? Yeah. 2, 12. Yeah, 48. Good so far? All right, rectangular prism. How many rectangles are showing? Not all 6 like usual. And not 4 because you got to count the bottom.
Oh.
Bottom counts. So 5, right? The top one is being covered up. All right, so give me the dimensions of one of the rectangles there. 11. What by what?
6 by 3.
Okay, 6 by 3 takes care of the one on the right and the one on the left. Everyone agrees? Or actually, and the front and the back. Everyone see that? The front and the back, the right and the left are all 6 by 3. Everyone agrees? So I can do four of them at 6 by 3. Or you can do 2 and then another 2. And then I have a 5th one, which is on the bottom. What's the dimensions of the one on the bottom? 3? 6 by 6. And is everyone all right? Well, I'm just doing 6 by 6 and not times 2. The one on top's covered up. You can't count it if it's covered up. I have no idea what this is. I'm not even going to guess. 24 and 3. Give you 2, 40. No, not even close. Let me try 18 and 12 and 6. I can do that. 72. 72, 36. 8. 108? Yeah. Ooh. Add those together. I'm not even just look at my answer key. 156 square feet. Cannot count what's covered up. Not bad for a 31-minute class here. Don't skip the hexagon tonight. Don't skip it.
Oh, wow.